So our group, our goal is to create biomarkers that are available to many people in homes, that are affordable and easy to use. There was a lot of discussion on how to encourage people to use these. If it's difficult to use, they will not do it, and they will try and then give up. And we discussed that the need also to make all of these biometrics available globally, both to databases that attempt to interpret them in the way that predict health and longevity with respect to foods and nutrition and substances. We've discussed the need for them to be continuous. There were some ideas presented on the ones that are implantable. And what do we consider a success? Success is when they're actually adopted and used. And I'm going to let maybe Nick, you could fill in. Yes, you can go next.
Yeah. So thank you. So I'm joined with Lucy and Rochelle, and our project was from the brainstorming to discuss a continuous biotracking implantable. So we had these how can we statements, getting that business case both for customers and the broader world, as well as making continuous biotracking. So we wanted to go beyond what traditional wearables do. Well, you have sleep, activity, and heart rate, but we wanted to track what wearables can't. So this is heart health, endocrine and biopsy labs, glucose monitoring. And we wanted to target markets to begin that are most beneficial with this case and then expand to the broader world. So we are looking at diabetics, we're looking at elderly care and emergency services with that 100% adherence that an implantable can offer, and the network effects. Just how 10 years ago you might have seen people starting to wear smartwatches in your social circle. We're interested in a similar network effect for implantables, and starting with the most needy in our population, and then as with our longevity group, expanding to the broader market. And with that, I'm going to hand it off to Lucy and Rochelle, who will talk about more of the business and technical aspects.
Yeah, so, I mean, these are all great proposals. The questions are like, how do we actually do this? And what are the technical risks associated with this? And the obvious thing with wearables in general, and like something I've like heavily like worked with in the past during my 2 years at Neuralink, is battery technology. How do you make this experience really like seamless, where you ideally forget that you even have this implant and you don't have to think about charging it in the same way that you have to charge a smartwatch? Because if you think about elderly people and the people that Ben just addressed as our first patient group, these are also people who are potentially not as technologically savvy to like actually like recharge their devices. So that's like one technological risk. The other technological risk that always comes with implants is how do we upgrade them? The big advantage about like an NFC chip or something that sits like subdermally, subcutaneously is it takes a very small incision to insert them, and it also takes a very small incision to remove them. And the other key thing that was mentioned during our workshop group yesterday when I posed the question, wouldn't you always want continuous tracking for biometrics over like doing this microsampling approach, was data privacy and what it means to actually like continuously have this device implanted that you technically cannot turn off. And that's mostly a question for cybersecurity. How do we gain trust from our like customers that this data is really in their hands? And yeah, these are like some technological risks that we will have to like face as a company. This is why we need funding. This is why we are racing. If this was already possible, someone else would have done it already. But I think if we manage to solve all these really challenging problems, there are some great hopes from this technology. that Rochelle is gonna.
Yeah. Okay, I can do this in 30 seconds. So ultimately what we want to do is close the very open feedback loop of this. So the way non-continuous blood monitoring works at this moment is you see a doctor, you get a blood appointment, you go to the pharmacy, or you go to LabCorp, you wait for your results. It is this incredibly arduous process. What we want to do is make that as tight of a loop as possible. The goal there is to bring healthcare essentially back into the autonomy of the user, who can then share it with the medical institutions who then need it, and can use that to better improve their healthcare. We want to increase the quality of life for them. Really quickly, just the standard Silicon Valley pitch as to credentials, Lucy's ex-Neuralink, I'm ex-Palantir here. We have whatever those universities are. But more importantly, we are partnered with other biotech organizations that are specifically specialized around distribution. And in the case of our technology, we are pretty uniquely positioned to have a fast go-to-market. And we have some technological risk. Lucy is very frank and honest about the challenges that we're planning on facing. And we also want to be transparent with the people that we're going to work with about that.
Thank you.
Okay, cool. Awesome. Done. I did my best.
We have 2 minutes for questions.
Oh, wait.
Questions. I have one. We had a fellow last year, Georges Casey, at OpenMind. They do basically a bunch of privacy-preserving machine learning using federated learning, homomorphic encryption, secure multi-party computation, and they are specifically focusing on similar applications. It's mostly in the biomedical data space, but it's more like a suggestion. They do awesome work, especially for very similar use cases. So you should totally contact them and collaborate with them.
No, that's super cool. And one background I didn't mention is I spent a lot of time in the CCC, Chaos Computer Club, which is
great.
a hacker organization in Europe. And as such, I have a very open source minded mindset. And one key feature of our product would be that the actual API that gives you insights to those metrics is open source. So people can choose if they want to use and trust our app, but they can also develop their own open source applications that implements reviewable crypto for storing this data and transmitting it to healthcare providers.
Thank you. Do you have anything to add? Or no? Any other question? Maybe one more? Yeah, David.
Aren't there patches that can be used, or some less invasive ways to monitor these things? That's one question,
Yeah.
and then a comment. Glucose monitoring, that's been solved, right?
Yeah. Let me just add that these guys are highly enthusiastic about their approach, and they wanted to convey it. We did discuss a multitude of approaches, and the goal at this stage is not to really dive in and say this is our product. We don't have a product. There's a variety of approaches to think about.
Yes, and to your point, there are absolutely a variety of approaches for potential extensions of this product. Essentially, once you create an implantable device, the sort of opportunities are bounded by the existing and developing technology around what you can do with an implantable device. So there's sensor technologies being developed now, there's drug delivery mechanisms being developed now. All of these can be made potentially compatible. Okay.
Thank you, guys.